one of the first sessions of today. So I'd like to ask you to imagine your journey over here. If you came by car, maybe you came by bike, maybe you live nearby, maybe you came public transport, but just imagine you came here by car. And you do the same thing as my math teacher used to do when it was an early class. She would dim the lights and turn on some nice music. But the music stops and the car's making funny sounds. It comes to a full stop and you get out and it does not look good. There is smoke coming out of your car. Maybe your bike, if you came by bike, is broken. So same story applies. You grab your phone, you pin in the number and you call. You call for help. And today I'm going to talk about what happens after the moment you call for help until the moment you are back on the road. And how does data and AI fit into all of this? So, the agenda for today is we're going to talk about who you're probably going to call. Spoiler alert, it's probably the ANWB. I will talk more about that. I'm going to talk about how we diagnose your problem, how we then send the right help to you, and how we are trying to learn for next time. I think I'm going to... No, I like to walk around. And hopefully by the end, you are back on the road. So, who am I? Let's start with that. I am Yke Rusticus. I am, among other things, a bird enthusiast. And I work as a data engineer at the ANWB. Again, I'll tell you more about that in a minute. But I used to work as a machine learning engineer and a data scientist. I have a background in astronomy. And I also studied AI. Now I live in Amsterdam. ANWB is in The Hague, but I am from Groningen, so I'm really happy to be back here. Now, let's rewind. You're calling the number, and let's talk about who are you calling. I already spoiled it a bit, but it's probably the ANWB. I'm saying that because 1/3 of the people in the Netherlands is a member of the ANWB. I'm saying member because it's actually the largest association of the Netherlands. We do many things, among others, roadside assistance, either for your bike or for your car. And that's what I'm mostly going to talk about today. But there's also other things, like you may recognize the stores, you may recognize this thing, but it's not there anymore. Road signs, bike signs, there's medical helicopters, the trauma helicopters, the infrastructure is ANWB's. Also experimenting with medical drones nowadays, and my personal favorite, bird books. I'm going to switch to this. No, sorry. I'm still figuring it out. But you probably don't know the ANWB as this complex organization that has different cloud providers. So when we talk about data and AI, we talk about cloud providers, and we have all of them, or all of the major big ones that are American. So Azure, GCP, I usually use mostly AWS at the ANWB, but we have all of them because it's a big organization. We also have different data architectures. We used to have this data fabric where there's a central team responsible for all the data in the organization, but we're moving more away from that, more towards a data mesh where each data team is responsible for their own data products. So now we have both, but yeah, we're transitioning, so that's a bit complex. And also the ANWB is founded in 1883, around the time where the first bikes were invented. And that was because there was no infrastructure yet for bikes. But that also means that for more than 100 years, this organization has functioned well without data and AI initiatives, right? So that's only kind of a thing of the recent times. So that means that there can be quite a distance sometimes between what is happening, what has been happening for so long, and what we try to do with data and AI. And there's thousands of people working at the ANWB. There's thousands of people that are a member of the ANWB. So there's just a lot of people that you, when you build data and AI solutions, you all want to involve in your efforts and in that story. And that can be a challenge too. So now we know who you're calling. You're calling the ANWB. So let's talk about what happens when we pick up. And it's about diagnosing the problem. So you have car trouble and you call. So how it used to be is you have someone to pick up the phone and, well, maybe if it's an obvious problem, try to fix it immediately. But by default, we would always send roadside assistance to you. And then we would ask, yeah, okay, what's the problem? Let's try to fix it. If that couldn't be fixed, there would be a transportation. The problem here is the diagnosis is only happening there when you already have someone at the spot. And to always send someone, that is quite inefficient, you can imagine. Quite expensive. That means we can help fewer people at the same time because we're always sending the available cars out there. So how it then used to be, but not yet the current situation, is, well, you can now and some time ago already report your trouble case through the phone. So actually 70% is now not calling anymore, but actually going through the app to say they have trouble. And, well, we still actually, some time ago, used to send roadside assistance by default. But about 5 years ago, we introduced a phone fix team that would try to fix certain cases by phone. So you can imagine that saving time for the person with trouble, if that's all they need, and also quite some money. But the problem here is the phone fix team used to manually select from thousands of car trouble cases which they think could be solved by the phone. So this manual process, yeah, could be subject to errors, leading sometimes to still have someone having been sent over there. So then the member having trouble actually has to wait even longer. So diagnosis still happening at the moment when we try to fix the problem. So that's not what we want. It's a bit better, but still not what we want. So how it's now improved is because, well, we put a triage, or call it a pre-diagnosis step, after the intake using the available data. And now we try to predict, based on certain aspects, could this be fixed by the phone? Is it likely to succeed? Or do we need to send a roadside assistance? And if we can, try to predict also the transportation. But the focus is now on these first two, because if you have this wrong, well, it's not nice for you because your car gets towed away, even if it's not necessary, and it's quite expensive as well. Now, and throughout this talk, I'm going to put green boxes in this process at the places where we use data and AI to automate things. So I already said we try to predict this, and it is your classical AI problem, right? It's a classification problem. Here we use XGBoost. If you're interested, trained on the structural data, so what type of car you have, maybe some structured trouble characteristics, and also open text field embeddings. So that's where some language models come in, because the member can fill in kind of what they see, what they hear, and we can interpret that into this model. But also, the moment when someone decides to call, there's also this automated transcription step. It's from a third party, but we have this in text as well. So we can use that, feed it into the model with some labeled data. Based on past cases, we can predict, okay, which ones are likely to succeed for a phone fix team, preferably. Otherwise, let's send a roadside assistant. Now, that's the technical part. But the hardest part is actually the fact that this used to be a process that had been going on for for quite some time. There's many people involved, and of course you want to involve all those people in your solution because they have the experience that you need to make your solution good. You want people to use your solution, and this whole change in process and all the people involved, getting everyone along, that's I would say the hardest part. So this requires more time and effort than the technical part. Now, in the future, your car is generating a lot of data, and the ANWB can read out some of that data if you give consent. And we are experimenting at the moment to see if we can predict whether your car breaks down. So even moving that diagnose step further to the left. Okay, so lessons about diagnosing the problem. This first step, for us, it's diagnose as early as possible. If you have the available data, if you have some labels, you don't always have to send someone to there to see what's going on. This can save a lot of time and money. Now, and as I mentioned, the technology was not the hard part, it was the people and the process. Because if you want your solution to kind of generate the value that you have in mind, and for us this was decrease the waiting time and reduce the cost, well, that value is only limited by how many people are going to use it and are going to trust your solution, right? So, now we've diagnosed the problem, and let's talk about sending the right help. And let's assume for a moment that we need roadside assistance because, well, our car was stopping, the music wasn't even working, so we definitely need someone to come and look at it. But now the question is, who are we going to send? Because you're maybe on the road to Groningen, and there may be different cars around you that maybe are on their way to another troubled case. Maybe they're on a break. Maybe they're at the end of their working day. So, yeah, and just to kind of paint the picture a bit further, there's hundreds of technicians on the road every day. And there's thousands of car trouble cases also every day. So this is quite a big problem. You can imagine a very fun data problem. But actually how it used to be is without so much data at all. Because, well, we talk about 20 years ago, the ANWB divided the Netherlands into 4 districts, each having their own building with dozens of, we call them dispatchers. So dispatchers are the people that look at car trouble cases, look at all the available cars in the neighborhood, and manually assign. So if a car trouble case appears, manually assign a car in the neighborhood to that car trouble case. So you can imagine this is, quite a bit inefficient. There's many technicians needed for this reason because of it cannot always be optimally planned, and there was a limited communication between the districts. So if you have trouble between the districts, you don't know if any other cars from the other districts are actually nearby. So how it is improved and how it's been working for 20 years, you can imagine with data and AI, is now we have a single planning center with only the dispatchers that were there. A few dispatchers needed. Now there's fewer cars needed because now if there's a car trouble case, it gets automatically assigned to a car of the roadside assistant. So more efficient, fewer technicians needed, single source of truth. So let's put that into our picture. We had this car trouble case, you have the intake with some transcription. We classify this as a case that needs roadside assistance. And now we have all these cars in the Netherlands and we have the dispatch step. So it used to be manual assignment, and now we use all the available data and optimization algorithms to assign the cars to the trouble cases. Now, what's behind there? It uses linear programming because it's an optimization problem, right? All of the variables that you see here, travel time, waiting time, if there's danger or not, they have an associated cost. And you can define that cost with the stakeholders, with the business, and you can calculate that cost for each possible combination of roadside assistant to the trouble case. Now, if you have all those possible combinations, you put linear programming, optimization algorithms on top of that, and you get the optimal, as you defined it, solution. And this is also part of the broader field that is AI. And that is a really fun part to talk about at work. The teams are responsible for this. Sometimes we talk about, oh, what kind of AI can we implement? And then we think, no, this is the best example of AI at the ANWB that had the biggest impact, actually. Now, there's more, because this also depends on the repair time, the estimated repair time, because we don't want people to overwork, right? So we take that into the constraints in this algorithm. And that is something that we can predict too. So this is a regression problem. So we used to use XGBoost for this, but recent experiments have showed that kind of using aggregated means over the car type and some other variables lead to similar results in a certain way. So we actually prefer the means because we can explain it better, people trust it more, and that way we can get more people involved. So it's a really fun part of the process, and the biggest kind of process change over the past 20 years. Now, another question you can ask yourself is, okay, but where do these cars come from? So just to expand the picture a little bit, this is a planning step. There's planners at the ANWB that predict, okay, how many car trouble cases do we expect today, and how many cars are we going to put and where? Now, you can imagine with current technologies, this is something that you can assist in as well with data techniques. So, yeah, forecasting algorithms. We've experimented with XGBoost and Profit, and it works, but it works on par with the planning people. So in some cases it can help them, but really here the technical part is not the difficult part. It's really getting everyone involved in that story and getting the experience that these people have into that solution as well, so that it can help them in the best way possible. That is still an ongoing process, but I just want to really highlight that the technical process is not the challenge. It's getting all of those people that we're building for involved in what we're building. So let's combine the steps that we had from the previous chapter. After this triage step, we now assume we need roadside assistance, but there's this phone fix team as well and the transport team. So preferably we do phone fix. If that doesn't work, we do roadside assistance, and otherwise we go to transport. Now, the lessons from this part: the largest impact solution in terms of data and AI was the least complex in terms of data and AI. I mean, now, and you see all of these steps, they are quite well-defined, narrow scopes. We split them out into different steps, and we see that when we build an AI solution, it will not cover that whole process. There's no general purpose agent that will do all of this for you. But AI really works well in these narrow defined scopes, because you can measure actually what you're doing if it works. Now, and linear programming is also part of AI. It's not all neural networks, LLMs, generative AI, and that is, it's a nice discussion point. So if you have other thoughts, come find me after the talk. So, learning for next time. You can think, okay, are we done? Because technically, if we've helped you, you're back on the road, maybe, right? But we, as ANWB, also want to learn from this, because you can ask yourself, okay, how are we going to improve this classification algorithm over time? Cars are changing. There's always going to be new cars on the road with new problems. And the phone fix team, we want to help them stay up to date with all the kind of trouble that we see on the road. And this data is not always available, right? Because the roadside assistant just goes there and helps them, and back on the road it is. So if the data is not available, we just ask. Okay, what did you do? How was it? Could this have been fixed by a phone fix instead? We need to know. Because with that information, we can fill a knowledge base. Knowledge base feeds back into the phone fix team and the roadside assistants, the other ones that haven't seen the case. And the question, could this have been fixed on the phone? We can use to say, okay, so this classification that roadside assistance were needed was incorrect. So let's learn from that and do better next time. But you can, well, you should take into account asking a question like that, could this have been fixed on the phone? There's psychological factors at play as well. So this is really a user experience, UX design type of problem as well. So keep that in mind. Now, when we talk about automation, this knowledge base is also something that we, for many years already, automatically get the relevant information for the specific car type and maybe some other filters that are easy to just get out. But recently, we've also been experimenting with RAG to improve the retrieval even more. So, about this last part, it's important to include this feedback loop early on. We put it all the way at the end of the presentation, but when you're starting a project, you need to keep in mind things are going to change. So how is that feedback loop going to look like? Because that needs a process change, and process changes need time. So start with that very early on when you start things like this. And you don't always have the data yet, as we've seen. Nowadays, there's data about almost everything, so you can falsely assume that, the data that you want is there, and otherwise, why bother? But sometimes you just really need to think about what you want to do first, and then sometimes the conclusion is we need to gather it. We need to ask it to the roadside assistant in person. Now, and then a lesson learned for us is as well, incorrect feedback is worse than none. So this is the user experience part that you really need to take into account because you don't want to train on wrong data. Now that's a lot of steps, a lot of arrows. I hope you're still with me. Well, you're still at the side of the road. Well, now actually someone went over there and helped you fix it. But we started like this, right? We started with a broken car, no music, and we talked about everything that happens after you call for help, or maybe you put it in the app, and how data and AI fit into all of this. So I hope you have a better picture of that now, but what I also hope you would remember from this is that the biggest impact solutions were the least complex, and they all operated in narrowly defined scopes. And over and over, different companies have seen that work best if you create AI solutions. This feedback loop is important to build from the start to really make sure your solutions stay up to date with the changing dynamic world that we live in. And we should remember that we are building stuff for people, and that we think about, okay, how can we make this simpler? How can we make this more trustworthy? Because in the end, it's not AI that helps people back on the road, but it's people, and we want those people to use those solutions as well. And hopefully that gives you enough to think about when you're back on the road, being able to listen to your music again.